Today's lesson is the first day of distance equals rate times time. We're going to focus on when two different people's distances will be the same. And all of these are going to be on the non-calculator part of your final exam, so no calculators today. So we have Sally and Betty are both leaving the grocery store to go to Sally's house. Sally leaves 40 seconds before Betty. Sally travels on her bike at a pace of 8 feet per second. Betty travels at a pace of 12 feet per second. For how many seconds has Sally traveled when both girls were the same distance away from the store? Okay, so that sounds like a bunch of mumbo jumbo. We're going to focus on this formula, and we are going to put it into a box using this formula. Distance equals rate times time. So the distance that you travel equals the rate, that's how fast you go, times the time, how long you go that fast. So if I go 60 miles an hour for 1 hour, I'm going to go 60 miles. But if I go 60 miles an hour for 2 hours, I'm going to go 120 miles. So distance equals rate times time. So we have Sally and we have Betty. And I don't know either one of their distances, but let's see what I do know. Sally leaves her house 40 seconds before Betty. So Sally actually gets a 40-second head start. Now that has to do with her time. So her time gets an extra 40 seconds. Now Betty's time is just T. Sally's the one that gets an extra 40-second head start. Sally travels on her bike at a pace of 8 feet per second. That's her rate. 8 feet per second. And Betty's travels at a pace of 12 feet per second. So Sally gets a head start, but Betty's traveling faster. So eventually Betty is going to meet up with Sally and pass her. And what we want to know is, for how many seconds had Sally been traveling? So I want Sally. When both girls were the same distance. Well, same means equal. So I want to know when their distances are equal to each other. So I take Sally, 8 times T plus 40, and set it equal to Betty. And then all I have to do is solve this. But again, remember, no calculator. 8 times T is 8T. Now 8 times 40, if you'll just do 8 times 4 and then add a 0 on the end of it. So 8 times 4 is 32 and then add a 0. And then to solve for T, I need to get my T's together, so I'm going to subtract 8T. So 320 equals 4T. Divide both sides by 4. 4 goes into 32 8 times, and then 4 goes into 0 0 times. So T is 80. Now that may or may not be my answer, but I've got to go back up here and say, okay, well, if T is 80, so Betty went for 80 seconds. Sally went for T plus 40, so Sally went for 80 plus 40. Well, 8 plus 4 is 12, so that would be 120 seconds. Well, again, remember, it said for how long had Sally traveled, so I actually want the 120. So a lot of times people get the box. It's not a problem. They can solve it. Not a problem. They even get over the fact that they don't have a calculator. But don't solve for T and then stop. You've got to go back and read the question and make sure you've answered the question. Marcus and his brother Sam leave their house for school. Marcus leaves 2 minutes before Sam. Marcus walks at a pace of 2 miles per minute. Sam walks a bit faster to school at a pace of 3 miles per minute. For how many minutes had Sam traveled when both boys were the same distance from their home? So I want Sam. So let's go chart. And I have Marcus and Sam, and Sam's the one that we want. Distance equals rate times time. Okay, let's talk. Marcus leaves 2 minutes before Sam, so he gets a 2-minute head start. Sam just T. Let's see how fast. Marcus walks 2 miles per minute. Sam walks 3 miles per minute. I want to know when they were the same. So I'm going to set them equal to each other. So 2 times t plus 2 equals 3t. Distribute my 2 and get my t's together. So t equals 4. Okay, so let's go back and figure out what that is. So this is 4. I think these are minutes. And then 4 plus 2 would be 6 minutes. And I wanted Sam, so I want that one. Hilary and Bart race around the track. Because Hilary won the coin toss, she gets a 10-second head start. Okay, let's go ahead and set up Hilary, Bart, Hilary won the coin toss. She got a 10-second head start. She runs 5 meters per second. Bart goes 10 meters per second. For how long had Bart, so I want Bart, been traveling when he catches Hilary? That means they are the same. So again, I'm going to set these equal to each other. So 5 times t plus 10 equals 10t. So t equals 10. So let's go fill that in. And then 10 plus 10 would be 20. And these are seconds. And we wanted Bart. So I want that one. Okay, this next one is a little tricky, so we're kind of cranking it up a notch. Alex and Ernie must go to the store before it closes. Alex leaves his house 30 seconds before Ernie does. I think that's supposed to say minutes. Yeah. 30 minutes before Ernie does. Alex leaves at a speed of 6 miles per hour. Ernie leaves at a speed of 12 miles per hour. How long had Alex been traveling when Ernie catches him? Okay, so there's a problem here. My speed is in miles per hour. But Alex leaves his house 30 minutes before Ernie does. I can't have minutes and hours in the same problem. So when I set this up, it's going to start out looking very normal. And I have Alex and Ernie. And it wants Alex. So let's talk about their rate. Alex goes 6 miles an hour. Ernie goes 12 miles an hour. All right, now let's talk time. Alex leaves his house 30 minutes before Ernie. If I write t plus 30, and this is in miles per hour, then what I'm saying is he leaves 30 hours before Ernie does. I need to put this in terms of hours. Well, how many minutes? What part of an hour is 30 minutes? And it's a half. So it's t plus 1/2. And I really want you to write 1/2 instead of a 0.5. Okay, so now I'm going to set them equal to each other because I want to know when Ernie catches him. So 6 times t plus 1/2 equals 12t. Distribute. Okay, to do 6 times 1/2, most of you can just look at that and know that it's a 3, but you know you can use my trick and go 2 into 6 goes 3 times, and 3 times 1 is 3. So no big deal. And then I'm going to subtract the 6t. And then I don't divide by 3, I divide by 6 because that's what's with the t. All right, and we've talked about this. What happens when the bigger number's on the bottom? That means I'm going to get a fraction. And 6 over 3 reduces to 1 over 2. So the time is 1/2. So then I come in here and say, okay, he's a half. And then what's a half plus a half. Well, that's 1. So this is half an hour, and this is 1 hour. It wanted... So it wanted Alex, so we go with the 1 hour. Two girls, Dawn and Kristin, put together gift baskets. Kristin started 4 minutes after Dawn started. Kristin puts together a gift basket in 5 minutes, and Dawn puts together a gift basket in 4 minutes. How many minutes had Dawn been putting together gift baskets when the two girls had put together exactly the same number of baskets? All right, so let's go chart. We have Dawn and Kristin. D equals. Kristin started 4 minutes after Dawn. So Kristin started 4 minutes after Dawn. So after. So Dawn started first. So this is minus 4. And some people say, well, could I just give Dawn a plus 4? Yes, absolutely. You'll get the same exact answer. So you can either give Dawn a plus 4 and keep Kristin at T, or you can give Dawn the T and then take 4 away from Kristin. It doesn't matter. Dawn puts a gift basket together in 4 minutes, and Kristin is 5 minutes. And I want to know when they're the same. So 4T equals 5T minus 4. 5T minus 20. Subtract 5T. Negative 1T equals negative 20. Divide by negative 1. T equals 20. So this would be 20. And then 20 minus 4 would be 16. And let's go back and read the question. For how many minutes had Dawn? So I want this one. So I want the 20. Okay, and then just to prove a point, I'm going to take this out. And I'm going to let Kristin be T and give Dawn the, was it 4 minutes? A 4-minute head start. And show you that you get the same thing. So 4T plus 4 equals 5T. Is that right? Was it a 4-minute head start? Yeah. So 4T plus 16 equals 5T. Subtract the 4T. 16 equals T. So get the same thing. And then you add 4 and get the 20. So you can see that when someone starts earlier or later than the other one, you can minus or add to the other one. It doesn't matter. Two students were racing home from school. Paul rides his skateboard and Kevin rides his bicycle. Paul leaves 20 seconds before Kevin. Paul traveled at a speed of 12 feet per second and Kevin traveled at a speed of 22 feet per second. For how many seconds had Paul traveled when both boys were the same? Paul and Kevin. Okay, so Paul leaves 20 seconds before Kevin. So Paul gets a 20-second head start over Kevin. Paul travels 12 feet per second. Kevin travels 22 feet per second. Everything's in terms of seconds, so it's all good. And I want to know when they're going to be the same. Okay, so that would be 12T plus, all right, now to do 12 times 20, just do 12 times 2 and then add a 0 to it. So 12 times 2 is 24 and then add a 0. Subtract the 12T. So 240 equals 10T. Divide by 10. To divide by 10, just let the zeros cancel. 24 divided by 1 is 24. So this is 24, and then 24 plus 20 is 44. Who did it want? It wants Paul, so it wants the 44. A bus traveling at an average rate of 35 miles an hour left the city at 10:30 a.m. A car following the bus at 50 miles per hour left the city at noon. For how many hours does the car travel before it catches up with the bus? Okay. I have a bus and I have a car. Okay, now the bus is traveling at an average rate of 35 miles an hour. So that's his rate. It left the city at 10:30. Well, that's not my time. That just tells me when he left. So the bus left at 10:30. A car following the bus at 50 miles an hour, well, that's the car's rate, left the city at noon. So here's my question. What's the time difference there? Between 10:30 a.m. and noon, what happened? Well, the bus got an hour and a half head start. An hour and a half. So this would be T plus 1.5. And this would be T. Okay, now, follow me really carefully on this. What I know I'm going to have to do next is I'm going to have to distribute this 35 here, which is not bad, but then there. And 35 times 1.5 is not pretty. And the reason I know that is because I'm going to have to half it, and 35 is not an even number. So I really don't want to go there. So how can I fix this? How can I not make it so that the 35 is the weird one? Well, if the bus got a 1.5 hour head start, then put that in terms of the car. Instead of doing this, tell me that the car lost an hour and a half. Because I can do 50 times t and 50 times 1.5 because I can have 50. That's really easy. So let's do that. Okay, so I'm going to take this out and make it look normal. Okay, D equals, the bus's rate was 35, the car's going faster at 50. I'm going to give him a minus 1.5 and him just a t. Okay, now let's watch and see how this unfolds. So 35t is easy. 50 times t minus 1.5. So 35t equals 50t. And then 50 times 1.5, well, that means I have 1.5 50s. Well, 150 is 50. Half of a 50 is 25. So 1.5 50s is 75. Then I'm going to subtract the 50. 35 minus 50. Going to be negative. See, 50 to 40 would be 10, and I got to go 5 more, so 15. Then divide by negative 15. Go be positive. Okay, let's count how many 15s are in here. So 15 and 15 is 30. And 2 more would make 60. And I need 1 more to hit 75, so it's got 5. So that's 30. 30 more, that's 60. And then 1 more would make 75. So t equals 5. And then 5 minus 1.5, well, 5 minus 1 would put me at 4. And then minus another half would put me at 3.5. So let's go back and read what we want. For how many hours does the car travel? 3.5 hours. Okay, so let's try this one just for one more example. We've got Sean and Curtis, and they go on a walk. Sean began walking 20 seconds earlier than Curtis. Sean walked at a speed of 5 feet per second. Curtis walked at 6 feet per second. So I've got Sean and Curtis. Sean walked at a speed of 5 feet per second. Curtis walked at 6. Sean began walking 20 seconds earlier, so he gets a plus 20. And everything's in terms of seconds, so we're good. So 5t plus 5 times 2 is 10, so 100 minus the 5t. So t is 100. 100 plus 20 will be 120. For how many seconds had Sean been walking? So I want Sean. So I want the 120 seconds. So really, the two tricks here are when you're given time, like the bus and the car problem with the 10:30 and the noon, to come up with the 1.5. But then also to make sure you know that it was not a good idea to put it here, that it is a good idea to put it here because I know I'm going to have to distribute this. And 1.5 times 50 is much nicer than a 1.5 times 35. The only other thing you have to really watch out for is when it gives you 30 minutes, but your speed is in terms of miles per hour. You need to make sure you change your minutes into hours. So again, feel free to pause, replay, do whatever it is that you need to do so that you're good with this. Thanks.